Hey, in this section we're talking about domain. You'll use domain many times in the calculus course, especially when we move to continuity. So you have three cases for domain. You've got a denominator, an even radical, which means its index is even, and then you have all other cases. I also put your interval notation rules on the sheet just in case you haven't looked at those in a while. So in these examples I ask you to find the domain of the function and write your answer in interval notation. Okay, so the first problem is f of x equals x squared minus 9. Okay, case 1 is, does this have a denominator? The answer is no, it does not have a denominator. Case 2 says, does this have an even radical? The answer is no, it does not have an even radical. So that means this is in case 3. So case 3 says all other cases, which means it's all real numbers. So the way we write all real numbers is negative infinity to infinity. Now what that means is you can plug in any number in the whole wide world and you would get a real number back. There is not a number that would produce something that would be an error. Okay, for example, looking at the second example, g of x equals 5 over x minus 3. You'll notice if I plug in 3, that gives me 0 on the bottom, and that's an error. So that's what I mean by an error. Okay, so looking at that second one, g of x, the first case is, does this have a denominator? And my answer is yes. So since it has a denominator, what we're going to do by using the rule is, it says set the denominator equal to 0 and exclude. Notice it doesn't say anything about the numerator. So if I set the denominator equal to 0, x minus 3 equals 0, I move the 3 over and x equals 3. But what's special about that is that the 3 is bad. 3 is what makes it undefined, so your answer can't be 3. So you have to write this in interval notation and exclude the 3. Okay? Let me get back to a different color. So if we're talking about a number line, and you have the number 3 here on the number line, that means all of these numbers are good, and all of these numbers are good. The only number that's not good is 3. So that means we would go as close as we can to 3 but not include it, and as close as we can to 3 on the other side but not include it. So that would be from negative infinity to 3, union 3 to infinity. Now the question I get asked the most is, you said exclude 3, but you put 3 in the answer, and that's a matter of the symbol. The symbol parenthesis means get as close as you can to the number but not include it. So in this case that would be something like 2.999999999. A bracket means include, but parentheses mean get as close as you can to it without including it. Anytime a number from here on out, Cal 1 through Cal 4, anytime a number comes from the denominator, it will use parentheses. Okay, so let's try a few other ones. Looking at the top one, letter K, I notice that it has a denominator. So the procedure with the denominator is set the denominator equal to 0 and exclude. Okay, since it's an x squared equation, that means I need to factor it. Okay, that's how it would factor, x minus 7 and x plus 3. I need to set both of those factors equal to 0. So solving it out, x would equal 7 and x would equal negative 3. Now remember, those came from the denominator, so those make the denominator equal 0. That would give us something undefined. So that means these guys right here are bad. You can't have 0 in the denominator. We have to exclude those. If you need a number line, use it. So if I put these on the number line, here's negative 3 and here's 7. I get as close as I can to negative 3 but not include it. I also have to take into consideration the middle, all the numbers between negative 3 and 7, and then all of these numbers on the far side. So if I get as close as I can to negative 3, I'd put parentheses there, as close as I can to 7, and so forth. So writing this answer out, I'm going to go from negative infinity to negative 3. And then from negative 3 to 7. And then from 7 to infinity. Oh, it took it off. Let's see if we can put that back up there. Okay, so that's how that would look, and that would be my answer. Now, I'm going to fix it really fast. It erased part of my work. Okay, so that's how that one would look. Okay, looking in the next one, H, you'll notice H does not have a denominator. H does have an even radical. What you notice about H is it's a square root. A square root means that the index is understood to be 2. So the index would be this little number right here. There's an understood 2 right there. So that's how we know it's an even radical. So going back to your notes on the first page, it says if you have an even radical, your procedure is to set the radicand greater than or equal to 0. Now also on the front page you see notes that say if you have greater than equal to, this uses a bracket. Okay, that bracket is huge because this is a multiple choice quiz, a multiple choice test, a multiple choice exam. Everything except the homework's multiple choice. If you pick parentheses and not brackets, you miss the whole thing. So you have to be really, 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 really careful with the symbol. Okay, so going back to what the instructions told us, they say you take your radicand and set it greater than or equal to 0. So we're going to set x minus 4 greater than or equal to 0. I'll add 4 to both sides, and x is greater than or equal to 4. Okay, in interval notation, that means it would start at 4 and go to infinity. Infinity always takes parentheses, and the 4 would take a bracket, and that's how that one would look. Okay, looking at the last one, letter M, the first question is, does it have a denominator? The answer is no. The second question is, does it have an even radical? The answer is no. It has an odd radical because the 3, the index 3, is odd. So the way that we work one like this, if it's not case 1 with a denominator, if it's not case 2 with an even radical, then that means it's case 3, and case 3 is all real numbers. So that means no matter what we pick, we're going to get a real number back.